Welcome, ladies and gentlemen. This is Team 3, composed of Federico, David, and Yihang, and we're working on ImproveWell's comments analysis in collaboration with Lara Mott. ImproveWell is a startup that is active in the healthcare industry. They have recently developed a platform which aims to improve the working environment by allowing the workforce to report problems and suggest solutions to those problems, which are then relayed to the managers. Right now, ImproveWell is providing a dashboard to the managers to keep track of all staff feedback. However, the dashboard currently can't sort these messages based on their topic, and for this reason, our task is to augment their platform by providing a RESTful API which enables clustering and labeling of these messages according to their main topics, to aid managers in the reviewing of staff feedback. In terms of system architecture, our solution aims to provide high stability by passing all data through a load balancer built into Microsoft Azure and balancing all traffic across a set of virtual machines, which can be spun up and down based on demand. And each of these will host both our visualizer as well as our API. Our API queries are handled by one of the servers, which passes this query to our model component. This component proceeds by clustering and labeling the query and returning the result back to the user. We tested our API with Postman and Locust.io and used custom Python scripts with libraries such as matplotlib to test our model component. As for our main technologies, how did we try, test, and build our solutions? Our front-end application was implemented in React because of its fast learning curve, the ability to create and reuse components, minimizing our code reuse, and making the code base more maintainable, and simply having an ecosystem of developer tools coupled with a helpful community. As for our backend component, the team decided Bottle was the best alternative considering its horizontal scalability and performance. It allowed quick routing and application of middleware for the API and made it really simple to interface with our models, considering they were both written in Python. While our technologies include Spacy and Jensen, which are two natural language processing libraries, alongside sklearn and NLTK, the natural language toolkit, which we use to implement our models component, which handles clustering and labeling. To be more specific, we use the pre-trained doc2vec, which is document to vector, model, which converts sentences to vectors, and then we used k-means, or a specific version of it called mini-batch k-means, which is applied to these vectors to cluster them. Finally, we use a variation of the text rank algorithm to apply labels to each of these clusters. Enough theory. Now let's have a look at how our system actually works. So, as you may have already seen, for the purposes of showcasing the functionalities of our API, the team decided to develop a simple front-end application using React for debugging purposes. It consists of three main components. On your left here, you see a text area, which is where we simply insert a list of messages that we'd like to process. And on the right, you see the control panel, which consists of two counters, a granularity counter, a count counter, and a submit button. The granularity counter is used to set the number of groups we'd like to split the messages into, and the count counter simply specifies the number of keywords we'd like to get from each cluster. So a typical use case looks sort of like this. Here we see the user entering a list of messages into the text area. The user then sets the number of groups by using the granularity counter. So in our case, the user will set it to 3 different groups. The user then sets the number of keywords they'd like. Here we'll use 2 keywords. After pressing the submit button, the user will be able to see all the clusters formed and the corresponding labels associated. In our case, every card represents a different cluster, whereas the color at the top of each card is based on the number of sentences in that cluster. Let's evaluate how we did. Overall, we're extremely satisfied with the results achieved, given the small dataset we received in order to train and test our models. We learned, incredibly, that machine learning can indeed be done without data, which is completely astonishing. Through the use of pre-trained models, we were able to classify messages with an accuracy exceeding 60% on average and 90% in best-case scenarios, with correct labeling most of the time. Another key achievement was our stable API, which is ready for use and can be easily scaled based on the client's needs, and has a wide array of unit tests as well as stress, load, soak, and isolation tests to ensure the API remains available at all times. Finally, while consulting with the client, we found additional use cases which allow the client to integrate our solution, meaning even though the solution was not specifically trained on the client's datasets, our pre-trained solution has achieved results that make it useful in multiple places in the client's product, from generating word clouds to dynamic topic filtering.